Everyone. This is our senior project presentation, and it will be on analyzing and optimizing drilling data utilizing machine learning. My name is Kenny Lau.
I'm Karan Bhatia.
Farzad Sunavala.
Sarwar Khan.
And this is our agenda. We're going to start with an introduction, and we're going to review our subject material. Next, we're going to talk about our goals, and specifically our time frame. We're going to be talking about our budget and our resources, and the HSE portion of our project. So our subject material. We're going to be talking about artificial intelligence, and artificial intelligence is defined as the ability for a machine or a computer to think like an intelligent human being. And artificial intelligence has multiple sections, one of which being machine learning. And specifically in machine learning, we're going to be talking about predictive modeling. And machine learning is basically, we're given our inputs, different inputs and outputs, and the machine is learning on the spot using those data to optimize parameters. Lately in the oil and gas industry, we have not been using data analytics as much as we should, but as of recently, we have started using that more efficiently. And we're going to specifically do predictive modeling, which will allow us to save time, reduce the cost, and improve safety, and all in all, make better decisions.
Hey guys, so I'm going to talk to you all about the usefulness to the petroleum industry of AI and machine learning. So firstly, where did our data come from? Our data came from our advisor's graduate student. We have permission to use field data that were for the sake of privacy and legal rights. We're calling it CH12 field data. Why are we doing this? We're doing this because machine learning helps us with engineers and managers of oil companies make better decisions in how to spend money, how to implement a certain technology, how to reduce risk, and a bunch of other factors that can overall help a company in the long run in a positive aspect. As I said earlier, improve productivity and ROI, lower asset lifecycle costs. It's a platform for innovation, and specifically with our project, we're going to be doing a lot of maintenance analytics for drilling equipment. Some examples of AI and machine learning in the oil and gas industry. So from our literature review, we found that ExxonMobil in total are big players in this, investing several $1 billion into R&D for AI in their drilling units. So some examples are that ExxonMobil are doing, they're inventing intelligent robots for natural seep detection, and Argos robots by Total, which are autonomous robot for oil and gas sites. Robots are clearly something that haven't been used, and it's not really a conventional technology in the AI and oil and gas industry. But by doing this, you can reduce a lot of risk. It's more eco-friendly. And also, it can also improve, as R&D shows as of today, that it hasn't been implemented yet, but it can also achieve a lot better results in terms of detecting oil and gas geology and potential reserves. Also, Shell, they have a virtual assistant platform. This virtual assistant platform is a machine learning platform where you don't need several of customer service and customer support representatives at a desk answering phone calls. It's a machine learning platform that pretty much programs all different types of queries and inquiries you can get from people all over the world, and it has a single computer essentially answering all customer support questions. And then finally, what I want to talk about is predictive analytics. So GE and Chevron are really big players in the oil and gas industry of this. The three main things you can use predictive analytics for are reservoir modeling and simulation. You can use it, as I said earlier, for geology and exploring different reserves. And specifically with our senior project, as you can see here, we're going to be doing well drilling event prediction. For example, we're going to analyze the drilling data. We can find potential kicks. We can find patterns in equipment failures and how to reduce downtime. Additionally, we can focus on increasing our ROP, which at the end of the day can save a lot of money and time. And so, in conclusion, these are just a bunch of examples of the AI and machine learning in the oil and gas industry. So here are project goals and objectives. Kind of spoke on this earlier. So specifically, we're going to predict the ROP while drilling using surface parameters as inputs. We're going to simulation optimization to maximize the ROP, and then the predict equipment failures and propose solutions to eliminate failures. And so as I said earlier, all of these combined, saving time equals saving money. So here we're going to individually talk about our specific roles and responsibilities. So my job is to prepare the data, and so I've actually been working on that this semester and pretty much done with it. So some examples of what I did: I found the problem description and defined the different parameters of the drilling data we used. There also was a significant language barrier. It wasn't in English, the raw data that we collected, so there was a lot of translations going on and communication with different advisors. We discussed the motivation and the usage of what we're doing, summarized the data just for us to kind of visualize it a little bit better. Example, histograms and scatter plots to kind of see different correlations and different drilling parameters of the data we're given. And then also me and Sarwar together are implementing the supervised learning algorithms, as Kenny talked about earlier.
My job was to clean the data using Microsoft Azure and machine learning with Python and R script. I cleaned the missing rows and edited the metadata and featured extraction, and also implemented super learning algorithms.
So after the data is going to be prepared and cleaned, my role is going to be the model building part, and I'm going to be splitting the data, which means that 75% of the data is going to go into training and 25% of the data is going to go into testing. So after training and testing the data, I'm going to begin iterations. So my end goal is to find the best iteration, to find the best machine learning algorithm. And I'm going to be testing various regressions, like I'm going to find the best iteration out of either linear regression or decision forest or neural networks. Also, I'm going to be handling the hyperparameter optimization. And after doing all this, I'm going to be analyzing the data and understanding the business in the data. After that, it's going to be the implementing supervised learning algorithms part.
Once the model has been built and tested, we will now evaluate the model, and that is where I come in hand. What I will do is I will score and evaluate the model, and what that means is I will determine which parts of the model is accurate or not. And that also goes in part of the ensemble methods: bagging, boosting, and blending. What really all that is it checks for biases and determines whether the data is going to be accurate or not, accurate enough for us to be able to use this. Bias is an absolute thing that we want to avoid, because with bias, our data would not be useful at all. And we'll also be doing extreme feature engineering, and I will also be working with Karan in doing supervised learning algorithms.
For time frame, this semester was for research and preparing the data, and next semester is going to be for implementing the data into like modeling and forecasting. And we're very proud that this semester we made all our time frame, and even during the winter break, we're going to be working on cleaning and preparing data and having homogeneity. And next semester we're going to do our model building, and we will evaluate the models and improve the results.
So I'm going to be talking about the resources we're going to use, and we've already used and we're going to be using in the future. So we're using the JMP Statistical Discovery and SPSS Statistics. These two softwares are free for LSU students on TigerWare. Also, we're using the Microsoft Power Business Intelligence and Microsoft Azure Machine Learning, which are two machine learning softwares. We're going to be working on Jupyter, which is the Python script, and RStudio, which is the R script. Also, our advisors are Dr. Mayank Tyagi, and his grad students, Nicholas and Roger, are going to help us. So next, I'm going to be discussing the HSE. Since we are totally doing our project on computers, so we don't require much HSE. So it's a low health and safety risk project, and the project is, as I've already mentioned, it's a 100% computer-based project. So there's no field and lab experience needed.
So these are our conclusions. Our future work is already been discussed. We're going to go through our milestones. We have them week by week, and so we will plan to follow those accordingly. We will plan to attend some workshops, because AI is such a broad topic, and there's always something to learn in terms of AI, machine learning, predictive modeling. And so we will plan to attend workshops and conferences to just increase our knowledge on this topic. We will be meeting with our advisors bi-weekly in case we get sidetracked, they will be there to keep us accountable. We will also plan to obtain additional data in case we would like to increase our range of just what we want to do. We're really eager for results, and we will currently seek feedback on the things we need to improve on. Thank you.
Thank you.
you.